Hey everybody, this is Dr. Robyn MacKillop with Get That GED, and today we are working on geometry, triangles specifically, and Pythagorean theorem, which you need to find the third leg of a triangle. All right, so let's switch and we'll get going. So we're going to start with perimeter and area of a triangle. Perimeter is always just adding up the outside measurements. So for a triangle, it's side 1 plus side 2 plus side 3. If we're looking at a triangle, let me find one that's got all 3 measurements. Maybe. So for this one, if you were just going to do the perimeter, you're adding up the 3 sides. So basically a perimeter is the fence. You're measuring the fence. The area, on the other hand, is everything inside the fence. So it's got a different formula, clearly. But perimeters for any shape, all you're doing is adding up the measurements on the outside. And that's your perimeter, your fence line. And then again, area is everything inside that. And the formula for triangle is 1/2 base times height. So let's take a look at some triangles. All right, again, to find the perimeter, we're going to add 10.3, 18.7, 15.6. And that is your perimeter. So that was 10.3 plus 15.6, does not matter what order you go, plus 18.7. Our perimeter is going to be 44.6. Not bad. We like perimeters. You're unlikely to get very many of them on the test. You may not see a perimeter problem at all, or you might get a really big one, who knows? But perimeter is not a problem. You're just figuring out what the measurement is on the outside. Then the area of a triangle is 1/2, that's just part of the formula, base times height. And generally speaking, the base is whatever the triangle is sitting on. So we'd use 15.6 as the base. The height for this particular triangle is going to be 10.3. So we're just going to punch that into the calculator. We've got 10 point, oh, let me do it in order, sorry. Let's do 1, arrow down, 1/2, arrow out, times the base was 15.6 times the height was 10.3. 80.34. That is your area of this particular triangle. And for these worksheets, you do both perimeter and area for every shape. Do not expect to find a relationship between the two numbers. It's just not there. They're very different measurements. Sometimes it'll look like a pattern because you're doing several of them. It's also unlikely that on the GED test, they'll ask you to do both for one shape. All right, so it's not too bad. 1/2 times base times height. And you can always use 0.5 for the 1/2 if that's easier to type in. So that would be area equals 0.5 times base times height. So let's try number 2. We're looking at a base of 4.2. Now, the triangle itself, if I cover this up, we don't have a height for it, do we? So if that happens, they generally will give you the height like this. They'll put in the dotted line. And that gives you the measurement from the top to the bottom. And then we're just going to punch that back into our calculator. Let me clear this, it's blurry. All right, so we're going to hit 0.5 times the base, 4.2. Oops, I didn't do that right. Let me clear that. 0.5 for the 1/2. Oh, you can't see that. And then times base. And then times the height here is 6. 12.6 is the area. On the test, you will not have to worry about these. Doesn't matter what the measurement is, the answers will take care of it for you. You just need to find the calculation. The perimeter of this one is going to be 10.2 plus 7.3 plus 4.2. That's going to be 17.5, 17, 18, 19, 20, 21, 21.7. So perimeter is really not bad. All right, an area is probably far more important. You are less likely to get perimeter questions. You are far more likely to get area, surface area, volume. All right, let's do one more and then we'll move on to some other things because I want you to get to the Pythagorean theorem today. That's an important piece. All right, so here on this triangle, we've got the sides and the bottom measurement. We've got the height. So the perimeter is just going to be side plus side plus side. So that's going to be 9.6 and 9 is 18.6, 18, 25, 30. If I added that up right, I think it's 30. I should do it on a calculator. And then the area is going to be 1/2 base times height, or you can use 0.5. Base times height. So that means 0.5 times the base is 7.4 times the height, which is 8.5. If you should ever get a triangle that doesn't give you the height, you're not going to be able to find the area. Because generally speaking, triangles don't necessarily have a height given. And a triangle like this, which is close to an isosceles, it's right up the middle. It's from the very tip to the bottom. And you don't always see those measurements. So if you get a problem and it doesn't have the height, it's not really easy to find it. You can with the Pythagorean theorem, depending on whether you have enough info, but it's likely not an area question. So do check that when you are practicing for the test. It could be a surface area question, which would be a different formula entirely, because those are here. Triangle, triangle, right prism. Very different. All right, so let's let me type that one in. We had 0.5 times 7.4. That was the base. Times 8.5 was the height. 31.45. You very rarely get whole numbers. You almost always have decimals. All right, how do you feel about perimeter and area of a triangle?
I need to work on it a little bit more.
Okay, and do you want me to do a couple more, or do you want to work on the sheets?
Can you do a couple more?
Absolutely. And the good thing is I sent the packets I sent to you had the answers.
I see.
So you can do a couple, check your work, wait a couple days, do a couple, check your work. All right, let's do this guy. So again, perimeter is measuring the fence line. So 15.1 plus 16.5 plus 15.3. That's
So the
going to be,
outside.
yeah, you're just the outside of the shape. So that's going to be 30.4 when you add those two sides, plus 16.5 is going to be 46.9. And again, use your calculator. Don't do things in your head if you don't need to, because a calculator will be more precise. And the nice thing about it is you can go, if you're using a calculator like this, a physical calculator, you can go up and check to make sure that you input everything correctly. Like if
So
you got a
everything-
weird number.
So everything's in addition?
Yeah, for perimeter, you're just adding.
Okay, I happen to pick up the same calculator you have.
Good, good, good. That's the one you need. And I will, as we go along, I'll teach you how to use it more and more, because it can save you a ton of time on the test.
Okay,
So this is your perimeter for this triangle. You're just adding the three sides together.
okay,
The perimeter is side 1 plus side 2 plus side 3. Whereas area is 1/2 base times height times base times height. And you do not need to memorize these formulas. You will have this sheet available to you during the test. And here is the area. There's your triangle right there, 1/2 times base times height. Your perimeter, side plus side plus side. And then when we get into surface volume or surface area and volume, you still have formulas. You do not need to memorize these. And I think Pythagorean's down here. It is right here, Pythagorean theorem. We're going to do that today. So let's do a couple more triangles. We need to find the area of this one. So the 1/2 is just part of the formula, and you can use 0.5 if that's easier.
so it's
And
for
then
the,
the base, what's that?
sorry, for the perimeter again, it's side plus side plus side.
Perfect. Yeah, anytime they ask you for a perimeter of any shape, you are just measuring the outside. That's
Now
it. It's like if this was a field and this was a fence, the perimeter is the fence line. The area is everything inside the fence. So different formula, different measurement. But yeah, perimeter is not bad. It would be really nice if you got one. I don't think you're going to see much in the way of perimeter problems because GED thinks they're too easy. They're not, because you can get screwed up pretty easily, especially when they give you a shape and they don't mark it all. They love these, or they'll give you something like this. And they only give you some of the measurements. So you have to go through and make sure you've got a measurement for every single line. I'll have to, if I have time, I'll pull one and show you. There used to be a perimeter question on the practice test that was something like that. And it's not hard to do, except they didn't give you all the measurements. You had to figure it out. So it was kind of a twofer. You figure out all the measurements, then you can add them all together. All right, so for this one, for area, we're going to do 0.5 or 1/2, because that's just part of the formula, times the base, which is what the triangle is sitting on. So 16.5. So 0.5 times 16.5 times the height. And they have to give you the height for this one because you can't really figure it out from there. 12.8. So area is multiplication, not addition. and you let your calculator do the heavy lifting for you. 0.5 times 16.5 times 12.8 gives you 105.6. 105.6. Excellent. And then look at this funny skinny triangle. It doesn't matter what kind of triangle they give you. They have to provide enough information for you to figure out what it is they want you to do. So perimeter, we're good because we've got 1, 2, 3 measurements for the sides. We're going to add those 3 together to get the perimeter. Then we're going to come to area, and it's going to be 1/2 base times height. So that will be 0.5 times the base, which is what your triangle's sitting on, times the height. And they have to give you the height for this one because otherwise you don't have it. So 10.8. That's your area calculation. And your perimeter is just 3.1 plus 15.1 plus 13.1. And again, you don't have to memorize these. They will be available to you on the formula sheet. If you are testing in a testing center, they usually give you a hard copy. And it's always accessible via the in online form during the test. There'll be a little box up at the top of your screen, formula sheet. So you can always access it. And I believe it's there for every test, even language arts, and you don't need it for language arts. You might need it for science, and you might need it for social studies. Not so much this stuff, but certainly mean, median will show up in social studies and science. Oh, and then at the very bottom, interest, distance, total cost, those will show up in social studies and science. This stuff is definitely all math. That's the only place you'll get it. This is the important one for slope. This one shows up on all 3 tests, just not language arts. Surface area, volume, perimeter, area. So you'll always have that available no matter what. And I sent you quite a number of worksheets. And again, the worksheets that I sent you have the answers on the back. So you can work on these, do a couple every couple of days to keep fresh. And then you can easily check your work. And if something's not working out, just take a picture of it and send it to me. It's just every so often there's a weird one. And sometimes it's just, you need another set of eyes on it. All right.
So question on number 6, the area, I got the area of the perimeter. Let me see, hold on. No, the area. What would be the equation for that one? The 5 times 30.
You've got it. I do 0.5 just because it's easier on your calculator. And your 3.1 base and your 10.8 height. And your calculator will do that nicely for you. 0.5 times 3.1 times 10.8, 16.74. Cool, huh?
Yes.
They're not terrible. It's surface area that becomes really clunky. And we'll do surface area, I think the week after next. And some of these look obnoxious, because some of them are. Surface area is the worst. Volume is really straightforward. Volume's pretty easy. Area is pretty easy. Once you're familiar, If you're not familiar, they're not easy. So if you're finding that they're difficult, just wait. After you practice a bit, then you'll be like, oh, hey, I got this. I've got this. I've got this. These suck. Or you'll be opposite. You'll be like, no, I love surface area. I don't like volume. Okay, now triangles are three-sided. Every so often, they give you two, and they want you to find the third. So anytime you have a triangle, let me put a piece of scratch paper. I'm a terrible drawer. It's going to look awful.
What are we looking at? What paper?
This one is, let me check my email that I sent you. It's 1, 2. This one is the 1, 2, 3, 4, 5th attachment. I didn't go over the second attachment. That's just triangle definitions. The third attachment is all perimeter. Fourth attachment is good practice.
So what does it say? FE on the top?
Oh, let me see that.
It's right at the top.
Up here.
Okay, so we're on A, paper A, okay.
Yeah.
I'm going through everything. I'm like, where is it at?
Yeah, I send you a ton, don't I? And I don't use it all in class, but that's so you've got it. So if you're working on your own during the week, you've got some resources.
Okay.
So any triangle, you've got three sides. It can be, the sizes can be any length. You can have really thin triangles. You can have really fat triangles. You can have right angle triangles. Generally speaking, triangles will sit on a side. Not always. Sometimes they'll make them so it looks like they're sitting on their point. But you can write them up. There's always a base, a bottom. So your one side is usually A, your bottom side or your base is usually B, and then the long side is C. And that's just the general way of classifying the lines of a triangle so that you can find them. Now we're going to use the Pythagorean theorem, which is A squared plus B squared equals C squared. That seems like a lot, doesn't it? A lot happening. Yes. So let's see if we can break it down a little bit. Let's go to number 1. And we're looking at 20.5. Oh, look, they labeled this one. They put the A on the bottom. That's perfectly okay. It's fine that they did that. This is your hypotenuse, the long side. This is your B. This will be your B for this particular one, and this is our A. So we're looking for A. So let's fill in this formula with these measurements. We don't have A, we are looking for A. Plus B squared, B was 20.5. And that's going to be squared because that's part of the formula. And then C is 24.01 equals 24.01, also squared because of the formula. So we are going to, this is looking like an algebraic equation, isn't it? They exist in geometry. So let's do 20.5 squared. 20.5. Use your little tent button right here, kind of kitty corner from the 7. That's your exponent. See, it puts it right up on top. Hit 2 and then arrow out of exponent mode. And I want to know what that equals. That is 420.25. So I've got A squared plus 420.25 equals, and then I need to square this 24.01. So 24.01 exponent key squared, arrow out of exponent mode, enter, 576.48 equals 576.48. Now, the numbers aren't great, but this looks like an algebraic equation. And what we want to do in an algebraic equation is get the variable to one side and all the numbers to the other. So this number needs to go away. We need to get it off of this side. So we're going to subtract it. We're going to subtract 420.25. And when we do that, that means we have to do the exact same thing on the other side of the equal sign. Minus 420.25. So this cancels. That leaves us with a squared on this side. And over here, we've got 8 minus 5 is 3, 4 minus 2, 6 minus 0, 7 minus 2, 5 minus 4. That leaves us with 156.23. That makes sense so far? Now, here's our thing. We need this to get down to just a. A squared equals 156.23. What do we need to do to break that down? So that just is A. Anybody know?
No.
We've got to find the square. That's a square root. Means we have to find the square of this number. And that's okay. We can do it because handy dandy calculator. Right here in the little green, right above this key, is your square root sign. You get to that by hitting the green button and then this button, then type in the number and hit enter. So let's try that. Let me move this down so you can see it. So green button, square root sign, there it is, 156.23. And we're just going to hit equal. So the square of 156.23 is 12.499 or 12.5. That means A by itself equals 12.5. Now that kind of makes sense when you look at a triangle. Let me grab this triangle that we were working on. These together so you can see. All right, so we started out with one side at 20.5, the longest side at 24.01, and we didn't have this one. When we first started to fill in the formula, we came up with 156.23 or a squared. But looking at this triangle, that 156 is way too big, isn't it? Because we've got a 20 and a 24. So we have to find the square root of 156. That's when we use the calculator and this little sign, and that gets us 12.5. Let's do a couple more of these because this can be really confusing at first. But this is basically your Pythagorean theorem. All right, let's do one with smaller numbers. Let's do number 4. All right, so we are looking for a squared plus b squared. Again, don't memorize this. This is on your formula sheet. Equals c squared. That's your Pythagorean theorem. We do not have a again, so we don't have anything to fill that in. We'll say b is 5 feet So we've got a squared plus 5 squared, don't forget that square, equals C is 6.93 squared. Then let your calculator do the heavy lifting. What is 5 squared? 5 times 5.
25.
Perfect. That's going to be 25. A squared plus 25 equals, I have to do this one on the calculator. I couldn't square that in my head to save my life. 48.02.
And how do we do this again? You go to the second, next to the
In
second.
this case, they gave us C. C is always the long side of a triangle. And they gave us C, so we filled that in. What we needed to find was side A. And because these are all squared, we have to make sure that we've squared the numbers. 5 was side B, the squares from the formula. Side C was 6.93, the square is from the formula. Then we kind of cleaned it up a bit. We're looking for side A. Side B, when it's squared, is 25. Side C squared is 48.02. This looks very much like an algebraic equation. So we're going to continue. I'm going to rewrite this so I've got some room. We are still looking for A. And what we've done so far is just using what they've given us and cleaning it up a bit. So we're done with this part of the formula and we're done with this part of the formula. Now we're looking at this. We need the variable by itself on one side and all the numbers together on the other. So going back to your linear equations, we're going to get rid of this 25 because we want to zero it out. So if we take 25 away, that's going to be 0 on this side, but it also means we have to do the exact same thing over here. So we're going to take 25 away from this side. Now these are gone. And that leaves us A squared equals, and then that's going to be 0.02. 8 minus 5 is 3, 4 minus 2 is 2. So now we have A squared. And look at this triangle. Does it make any sense at all that this would be 23 when we've got a 5 and almost a 7? That's not bigger than that, is it? So that's kind of our tell that we have one more step to do with this 23.02, because we need this to be just plain old A. That means A is going to equal the square root of 23.02. That's what we need to punch into the calculator in order to find A. And again, that button is kitty corner, or no, right next to the 7 up above. So you hit the green button, hit your square root sign, type in your number, 23.02 equals, excuse me.
Bless you.
Thank you. And we end up with 4.8. So A equals 4.8. Now, if we look at the triangle again, 4.8 makes a lot more sense for A, doesn't it?
Yes.
Yeah, because now we've got a triangle that's 5 feet by 4 feet by 6.93 feet. That makes a lot more sense. So that's kind of your clue. If you get to this point on your Pythagorean theorem, that is very likely going to be one of the answers, and it won't be correct because you need to break it down one more. So GED loves to do that too. They make you do all that work, and then they give you this answer as a possibility. So a lot of people stop right there, forgetting, oh, wait, that's a squared. I need to get it down to a, which means I need to find the square root of this number. Now it makes more sense because if you come back up here, 5 feet, 6.93 feet, 4.8 feet. So the Pythagorean theorem, while it is not difficult in its calculation, it can throw people off because of right here. You just have to remember that if that's still A2, you have to do this. You have to find the square root to make that A. And then you can just double check your triangle and see if that makes a little more sense. Because again, we wouldn't have a 23-foot side when the others were 7 and 5. Let's do a couple more of these because I think this can be pretty powerful when you get it, but you have to see it a few times before it really gels. Because it's just like it's just got an oddity in it, you know, that extra step. All right, let's do I have another one with low numbers? I guess not. We'll do well, let's do number 3. Where'd it go? There it is. So this one is interesting. It's going to be set up slightly different. We looked for A on the other two. This time we're actually looking for C, which makes more sense when you think about the Pythagorean theorem. A2 plus B2 equals C2. They gave us A and B. We're going to find C. And just so you know, this is called the hypotenuse. And that is the longest side of a triangle. So in the Pythagorean theorem, A squared plus B squared plus C squared, the hypotenuse is always C. All right, let's try this one. I'm going to write it just so you've got it. A squared plus B squared equals C squared. And we've got A, 16.4. That's from the measurement. This is from the formula. Plus B squared is 12.4. That's the measurement. The exponent is from the formula. And that equals C squared. So we are just going to use our calculators and we're going to find out 16.4 squared plus 12.4 squared. And that will look something like 16.4 tenth button squared. Get out of that. And in this case, because they're both on the same side of the equal sign, we can put the plus in. We can do this whole equation. We can say plus 12.4 exponent button or tenth, 2 arrow out of that equals.
Which is the 10th button again?
What's that?
Which is the 10th button again?
So that is right, this funny little
Arrow
kind of looks
pointing
like
up.
it looks like a tent or a carrot. And that's how you get an exponent. As soon as you hit that, you'll see the thing go up high. Perfect.
And then how do you get back out of it to put the plus?
With your arrow key. So this guy right here, this is up, down, sideways. Just click once to the side and it drops down to where it needs to be. If you don't get it out of there, it'll do the entire equation up in the exponents and it won't work.
Okay, I got it.
Yeah. And that's really just practice using your calculator. You'll get really used to using the arrow key to get out of modes. And what did we say? We said c squared was
422.72.
yeah. Perfect. So we are now done with these two. We just need to get this one cleaned up because right now it's still c squared and we need c, which is the square root of 422.72. And this is super easy to find on your calculator. Again, this time your button is right above the x squared button. You've got that little green square root, green button, square root. Oh, wait, let me clear that. Otherwise it's going to be a mess. Green button, square root, 422.72, enter. 20.56. So C equals 20.56. And if we go back and look at our little triangle, it was right here. So one side was 12.4, one side was 16.4, the long side is 20.56. That fits. 422 did not, did it? That would have been a super long hypotenuse and nothing left. So perfect. So this is your style for Pythagorean theorem. Fill in what they give you. The easier ones are when they make you find the hypotenuse, but sometimes they make you find one of the sides. And that's what happened over here. They gave you the long side. They gave you the B side. You had to find A. Over here, you just had to find the answer. Side plus side squared equals, that's the calculation. This is the correction to C. This is the answer. Let's do another one, because I want you guys to be comfortable with Pythagorean theorem. Let's do number 6. And again, we are looking at a squared plus b squared equals c squared. And they gave us a, we're going to say 11.1. That's the measurement. The exponent is from the formula. Plus b. B is 6.6. The exponent is the formula. And we are looking for c squared or that one. So we're going to figure out these numbers based on their exponents. 11.1 to the second power. So 11.1, 10th button, 2, arrow out of that mode, enter. 123.21. That gets rid of that exponent. Plus 6.6 squared, which will be 6.6 10th squared, arrow out, enter. 43.56. We add those together and we get the c squared. Can I do that in my head? That's going to be 7, 5, 7, 3, 3 is 6, 6, 1. Did I do that right? 123.21 plus 43.56. Oh, yes, I did. Woohoo. Don't always do it in your head. Let your calculator do it. I've screwed things up when I've tried to do them in my head. So what we're dealing with is we now have c squared equals 166.77. But if we look at the triangle, it does not make sense that this side would be 166, does it? That's our clue that we have one more step. We have to break this down to just C. And we do that by finding the square root of 166.77. And that's super easy to type in. Again, green button, square root sign, 166.77, enter 12.9. So C equals 12.9. And that makes more sense, doesn't it?
I got lost somehow. I don't know where.
All right, let's do that one again.
Please.
Yeah, because again, well, especially if this is fairly new or you're revisiting it after many, many years, it's a lot to keep track of. And that's probably the biggest thing with the algebra. There are so many little rules and things that you have to remember. It's super easy to skip something, especially when you're stressed and taking a test. Super easy to skip. All right, let's do this one again. So our Pythagorean theorem, I'm just always going to write it down because that way you get used to seeing it. It just means the two sides squared when added together equal the long side. And they gave us A and B. We are looking for C. So we can say 6.6 is A squared from the formula. B is 11.1. That's all from the triangle. Squared is from the formula. And this is what we're looking for, C squared.
Okay.
Now, what we have to do is figure out 6.6 squared. What does that equal? And let your calculator do it. Save your brain. 10 to arrow out, enter. I just want to know what 6.6 squared is.
43.56.
You got it. So I'm going to rewrite this with the better answer. Now I'm going to figure out what 11.1 squared is.
$123.21.
Perfect. So we got rid of the squares on those. It's a little bit cleaner. We're still looking for C squared. So to find that, we're just going to add these two together, aren't we?
Yes.
And that is going to give us 166.77 equals C squared. But we have one more step, and we know we have one more step because if that was our measurement, we'd be looking at 6.6, 11.1, and then 166. That doesn't make sense. So we know there's another step. And that step is to lose the exponent from the C. And to do that, to get this down to C, we have to find the square root of this number. So now we'll be able to find C. And what's nice is the calculator will do it for us. So we want green button, square root sign, 166.77, enter. We just want to know what it is, 12.88 or 12.9. And that's your third side, all done.
Okay, I got that.
And it's not a small bit of writing, is it?
No.
Yeah, you've got, it takes some time. Even if you totally get it, it's still going to take a minute or two. And that's one of the things, that's the nemesis of everybody who takes those GED tests, is the time. And they're very good about giving you problems that aren't necessarily difficult for you to do, but take time. Because that's quite a bit of information. From formula to putting in the measurements to calculating so you can get down to the C2. Then you've got one more step, then you're done. But they like this because you're going to spend a minute or two on it. And you know, that little clock is ticking down. It's a really good way to stress people out. So don't let it. That was helpful, right? It's a really good way to stress you out, but don't let it. It'll be great. You'll be fine. You will be fine. So I think I gave you a bunch of these as well with answers. So you can practice, and don't do a whole page, do a couple at a time. So like if you're going to do some math homework today, do 2 of the problems, see if your answers match. If they do, excellent. Wait a day or 2, do 2 more. If your answers match, excellent. Wait a day or 2, take 2 more. Because that's how you're going to put it into your long-term memory. If you did the whole page today and then said, well, I'll check it next week, you're going to forget how to do it in that time frame because you haven't had the practice, the consistency. So whenever you see big pages of math, just do a couple, unless you have a horrendous teacher who's like, no, you have to do 30 of them tonight. For those of you who've got kids, it's so annoying when they bring their math homework home and they're like, Mom, I've got 40 problems I got to do. That's not how they're going to learn. They're going to know how to do it tonight. They're not going to remember how to do it by the time the test rolls around. So just do a couple, give it a go, check your work. If you find that you cannot come up with the right answer, that's, take a picture of it and send it to me and I'll work with you on it, because it happens. Sometimes there's an error in the problem. Sometimes there's an error in the way we're processing it. And it just, sometimes you need another eye to look at it, and then boom, it's like, oh, I know exactly what happened. And that's the biggest thing. It's okay if you get a ton of them wrong, because it just means you need to do a couple every other day until it makes sense. And it will make sense, believe it or not. But you have to train your brains for math, because I would imagine most of us did not have great math instruction in grade school. That's when we needed it. That would have set our synapses. Now, do you want me to do something weird, or do you want me to wait?
You can go ahead and do something weird. Just let me know what page you're on.
Okay, and this is the very last page on the attachments. And the reason I did this is because it forces us to kind of use those linear equations again. Let me grab a piece of scratch paper.
All right,
So
I'm
this one's a
looking
little
for-
different. Let me take this up so you can see it. I'm not sure that you will see one of these, but you could. And that's one of the reasons why I want to do it, because it's just another way to present information that you technically know how to do. But if you haven't seen it before, you feel like it's brand new, and that's no fun. You don't want to have that happen during the test. It's like, wait, I studied. Why does this not look familiar?
Okay, I found it.
Now I'm going to do a little bit of background on angles, because there's something you need to know about angles. So anytime you've got a line or a side, and there's another line coming out of it, the sum of these 2 angles equals 180. No matter what. Doesn't matter if it's perpendicular. Well, that's not really, but You'll see that for a right angle, 90 and 90. So the angles together equal 180. Whatever this angle is, let's say this angle is 70. They have to give you one. You can't figure it out without one. What is the other angle going to be if they both equal 180?
90.
Little bigger. So that's your total. Take away 70. Oop, my pen's not working. So that's going to be 110 because these two are always going to equal 180.
Okay.
And that's what you need for this page. They want you to find, they want you to find this angle. Oh, so the exterior is equal to the sum of the two opposites. So this one's a little bit different. This is why you actually get stuck reading instructions, because sometimes they give you some weird instructions. So in this case, this outside angle, outside of the triangle, is equal to the sum of these two angles. And this is 4F and 7F equal 132. And again, the reason I gave you this page is because it's another way to present information. And technically, you know how to do it, but if you've not seen it this way, it feels brand new. So let's go 4F plus 7F equals 132. So what is 4F and 7F? Doesn't that look like a fairly simple linear equation? We need to separate the 11 from the F. That means we're going to divide out the 11. What we do here, we have to do here. These 11s are gone because 11 divided by 11 is 1. Leaves us with F. And 132 divided by 11, I think, is 12. I got to run my calculator. Times 11. Yep, it's 12. So that means F is 12. Again, this is a very different way of looking at things, and it's not particularly familiar. So for this page, if you do this page, you're going to be looking at each triangle. They're going to give you the angle on the outside, and the angles inside equal that.
So that one is already done?
Yeah, this one is done.
So that one's just, the answer is 11?
Yeah, no, the answer is 12.
12, I
F
mean 12.
equals 12. And really, it would be 4 times 12 and 7 times 12. And you could figure this out because it's 180 minus 132. But it's a different way of presenting. And it's
Okay.
not common. And that's why I'm giving it to you, because GED would do something like this. It wouldn't be in the Kaplan book or anything, but they'd be like, oh yeah, we're going to throw this one at you. So for here, again, the two inside angles equal the outside angle. We're going to start with 3x. That's one of the insides. Plus the other one is x plus 40. You just type those in or write those down. And they equal that outside angle of 120. Now we're going to clean this up. We've got 3x and 4. So we've got 4x plus 40 equals 120. Looks like a linear equation. Because it is. What's our next step to clear the number? Yeah, we're gonna get rid of that 40. Because it'll clear it from this side. We have to do the exact same thing over here. So these 40s are gone. That leaves us 4x. 120 minus 40 is 80. And we've got one more step. We need to separate the 4 and the x. You got it. Good job. That means 4s are gone, leaves us x. X is 20. And if they had you come back and plug that in, this one would be 3 times 20. This one would be 20 plus 40. So that would be 60, 60, 60. Which makes sense. If that side is 120, that side's going to be 60. But this didn't have you find the interior angle. It had you calculate these two angles equaling the exterior. Do not let this page confuse you. If you are not ready for it, ignore it. We can do this again because I really want you to be comfortable with Pythagorean theorem. Finding that third side of the triangle. And the big thing to know is that C is the long side. So if they give you C, you have to fill in the formula just like that. They gave you one side and the answer, so you have to find this third side. When it's this, then it's one side plus one side equals this side. That's a lot. You got a lot today. How are you feeling?
I'm feeling okay.
Excellent. And again,
Can you
do
go
a
back to
couple-
where you, sorry, Robyn, can you go back to where you wrote everything so I can look at it again?
Oh, absolutely. For
Number 2.
this page or
Yes, that page. Okay. Yep, I got it.
awesome. And this one's just really good because it's such a different way of presenting. And I've had students come back from the math test and say, you know, I thought I was really good at slope and graphing, and they gave me a question that was brand new. What they did was something like this. They turned what you're used to inside out, basically, and forced you to look at it a different way. But who's got time to do that during a test, right? The last thing you have is time to, wait a minute, this might be familiar if I think about it, but we don't have time to think about it during the test. So it's really aggravating that they do that to you. It's like present the way you present the way students learn it. So it's kind of fun though. And triangles are a big deal. They're everywhere. Triangles are stronger than boxes. I read that somewhere and it was really interesting. I should find that article. I think the article is something like, why don't we live in triangle-shaped homes? We live in box-shaped homes, don't we? Our apartments are square, our houses are square, but really this is stronger. But you'd have a hard time putting your couch right here. Your couch fits much better here. All right. So let me check really quick. I think I've got a conflict tomorrow again. I do. So there's not going to be a language arts class tomorrow because I've got another meeting. I'm going to have to find a better time, I think, because my Tuesdays are bad now. And then Wednesday, we should be just fine for science.
Okay.
But I'll find something and send it over for language arts so you've got it and you can work on it. And I did find, I told you guys a long time ago, I had that big packet of stories. I found it. So I need to get that to you. I'll send that to you. It's something to read, and it even has questions on it. So it's great.
Okay.
But lots of different styles of reading. Yeah. Excellent. How are you guys feeling? Ready to?
I'm physically feeling sick. I have the flu.
Oh no.
So I said, I'm just gonna jump on class and just try to get something productive other than the flu.
Excellent. And you've done really well for feeling crappy.
I had to get my mind off of how I'm feeling.
Well, if you need more math, I can send you a ton. That'll keep you
I can
occupied.
see. Thank
So,
you, Robyn. You're so helpful and everything.
oh,
Really
great.
appreciate it.
I love it. Thank you. All right, I will not see you all tomorrow, but I will send some language arts and social studies to work on. And then I will see you Wednesday for science. I don't know what we're going to do yet. We really need to do velocity, which means I need to get some stuff together for you.
What are we?
That
What
shows
will we be working on?
Velocity, maybe,
Okay.
if I get my act together.
Okay, you will.
All right. Well, you all have a great day, and I will see you on Wednesday.
Well planned. Thank you. Bye, everyone.
Sounds good. Have a good one, guys.
You
You too.
too.
Bye.